Fossil fuels, coal, oil, and natural gas are the result of millions of years of natural processes. Their journey began over 300 million years ago, during the Carboniferous period when Earth was covered with dense forests, swamps, and oceans teeming with life. When plants and animals died, their remains accumulated in layers on land and under the sea. These organic materials were buried under layers of sediment, cutting off oxygen and slowing decomposition. Over millions of years, immense pressure and heat transformed these buried remains. Plants formed coal, while marine microorganisms became oil and natural gas. Crude oil and its derivatives have played a pivotal role in the history of global economic development. With a wide range of applications from energy production, chemicals, plastics to pharmaceuticals, crude oil is an indispensable and valuable resource. However, this resource is not infinite. This requires reasonable exploitation and use. In addition, technological developments have opened up new ways to supplement fuel sources, such as recycling waste tires for oil. This method not only reduces environmental pollution, but also contributes to the conservation of natural crude oil reserves. The process of extracting crude oil involves finding, drilling, and processing it to refine it into valuable products. Exploration process uses advanced technologies to locate potential oil deposits underground or on the seabed. Geologists often perform structural geological analysis, studying rock and sediment characteristics to identify areas that are likely to contain oil. Seismic waves are a common tool where sound waves are emitted and reflected back from geological layers. Based on the time and intensity of the reflections, experts can create a 3D map of the oil-bearing rock layers. Once an oil field is identified, the extraction process begins with the installation of drilling rigs. The rigs drill into the ground or seabed until the desired oil layer is reached. The wells are then equipped with high-pressure pumps to push the oil to the surface. Drilling is the next important step, where a well is drilled to physically test the existence and quality of oil. This is an expensive but necessary process to confirm the potential of an oil field before large-scale exploitation is undertaken. Every year, millions of tons of tires are discarded, creating a large amount of non-biodegradable waste. Old tires not only take up a large storage area, but also cause serious environmental pollution, from toxic gas emissions when burned to soil and water pollution. Recycling tires into oil is an effective solution to solve this problem, while also creating an alternative source of energy. The process of recycling tires to get oil is mainly based on pyrolysis technology, which is a highly scientific process. Waste tires are collected, cleaned, and shredded to increase efficiency in the processing process. Chopping helps maximize the area exposed to heat. The tire is then put into a closed pyrolysis furnace, heated to a high temperature of 300–500 degrees Celsius in an oxygen-free environment. Under these conditions, rubber decomposes into gas, liquid, and solid compounds. The liquid compound condensed from the pyrolysis gas vaporized through the tower trays is recovered and processed through multiple stages for use as fuel or feedstock for petrochemical products. The remainder consists of carbon black, valuable in the production of rubber and dye products, and steel, which can be reused in metallurgical processes. Recycling tires helps reduce the amount of rubber waste that is difficult to decompose, minimizes the impact of soil and water pollution, and limits air pollution caused by burning tires. This process also reduces the risk of fire and explosion and harmful gas emissions. Recycle tires as an alternative source of pyrolysis oil, significantly reducing the need for natural crude oil extraction. This process not only helps maintain existing oil reserves, but also contributes to ensuring national energy security.